Okay, now we're live.
Thank you. So, welcome to this talk about how our critical systems fail and the things we do about it. So, today we'll briefly cover who is Norsk Helsenett, some of our failures, some of the things we did about those failures, the things we've learned along the way, and where we think we will go forwards. So, briefly about us. Today I have Fredrik here with me, my good colleague.
Yeah, I'm Fredrik. I'm a developer at Norsk Helsenett. I worked there this time about 1.5 years, but yeah, I'm a developer. I've been developing stuff for about 20 years, software, teams, solutions, basically myself, mostly. And this is Simon.
Yes. I also work as a developer at Norsk Helsenett. I've been there for quite some years now, worked in various roles, many projects, yeah. So on to the fun stuff, or...
Yeah. Norsk Helsenett, what are we? Until recently, nobody has heard much about us, but we want to be more visual to the public. Our goal is to bring the health sector together, to make the systems in the health sector communicate. And what we are right now is sort of built on our pedigree up through the years that we'll go through in this talk. And mainly, we connect services, we connect people, we connect data, and
at center there, how we all got started. So at the very beginning, the hospitals in Norway wanted to connect with each other, collaborate, and they figured out here in the mid-early noughties that the internet, this new thing, was the cool way to do that. So they wanted a network built, and they made this new company, Norsk Helsenett, to do that. So trenches were dug, fibers were laid, network got up, and some basic usage started to see the day with some video conferencing. Not the modern kind of thing you think of with doctors sitting on the other side of the world doing open heart surgery on you, but more basic video conferencing. And now that they had this shiny new network, they wanted to use it for a bit more. So they figured out, how can we enhance our collaboration? Well, messaging. So a messaging standard was chosen, built on electronic data interchange, which is built upon X400 email. If you wonder why you haven't heard about that, it's mostly because it was replaced by SMTP, which is the same way to do messaging. But anyways, the standard was chosen, and at the core of this, you have the payloads that is shipped back and forth, whether that is that a patient is arriving at the hospital, or that prescriptions are given, or that the pharmacies receive them, or some lab work is being done, information that you really want to flow through the healthcare sector. And the interesting properties for us in the beginning were all these other metadata, because the payloads themselves encrypted by the sender for the receiver, signed, all of that, but loads of metadata about who is the actual sender, who is the intended recipient, about who is this message, what keys are used, lots and lots of data. And in all of this, then, there are many actors. You have the hospitals, you have your primary care doctors, you have the pharmacies, the labs, and okay, we have this messaging standard, but how can people find out about each other? I mean, surely we could still send big phone books with addresses and public keys, and that would be kind of horrible. So they decided that to facilitate that messages start flowing, we need a registry of addresses that people can look up and figure out how to communicate. And that is how our development journey really began. We made this simple solution with addresses, a nice normalized database, simple VCF so service on top of it, and we were off. Messages did start to flow. Here, millions per year, not per second, so maybe not that impressive, but still it was quite a lot for us. In the beginning, a bit slow, and then gradually it grew bigger and bigger and bigger. And as the flow was starting to pick up, the sector started talking about messaging, amazing, but there's something that is maybe a bit off.
Yeah, things weren't quite peachy, but we couldn't pinpoint what was the problem here. So how could we find out what really bugged us here? So we had this standard, and as Simon said there, this is a quite new standard. At that time, really new standard. And it was only in theory sort of written down. The only implementations being done were actually us in the health sector. And that is quite interesting. Because how this sector works is, or how this interaction works is that you have the different parts, around 8,000 different communicating parts. And each one of them has software coming from a vendor, not the same vendor. And here you have 3 parts. So let's say they have 3 different vendors. Every vendor did their own read-through of the standard. Because there were no implementation of the standard, they did their own sort of interpretation of the standard, and they said that, okay, the messages should be so-and-so, and they started sending back and forth. And here's the problem. Since there were no implementations, no SDKs, no nothing to follow that we programmers like to do, they sort of, interpreted this themselves. And if I interpret something, Simon interprets something, we probably won't interpret it the same way. Probably, I don't know. Another problem here is, since it's a new standard and nothing's created, sorry. Skipping to the start, I hope. Let's go back to where we were. We were about here. Okay, so how the traffic works here. So we have the sender, we have the receiver. Okay? The sender, one vendor of an application, the receiver, another vendor of the application, but the traffic goes through Norsk Helsenett. Quite good. So what can we do to sort of find out what is really wrong here? We had some hunches. Yeah, we think that they have interpreted this standard differently, all the vendors. So how can we implement this? Should we create something and put it out to the vendors? And no. We found out that we need to do something central. So what we were doing is, or found out that we were going to do, is create a validator. Yeah. And what we were wanted to validate wasn't the payload. The payload is a secret. The payload is only something that the recipient is going to, or the receiver is going to need. We don't want to mess with the secrets or the lab results or the sensitive data. Only thing that we are interested in is the metadata right now. So what we did is actually sit down, interpreted the standard ourselves, created this validator, had great help with somebody who knew the standard, read it a couple of times, and gave good input. We created our own test messages that was validated, and we did all that red-green stuff. And when we were finished, we sort of, okay, We tested it on all our test messages. Yeah, it runs, good things. How about some real good production data? Have done that before. So we took 1 day's worth of live data, ran it through.
And the results came in.
Yeah, the results came in. The results were actually 0 of the messages being sent was validated correctly according to our validator.
And
So-
at this point, clearly the consultant had to have messed up something.
Yeah, the consultant. Yeah, that was me, obviously. But we had a different team going through the code, going through the messages, stepping through it, and what they actually found that it was correct. The validator worked. So we got it confirmed. None of the messages being sent early days were correct. What can we do about this? So what we did about this is actually creating a certification track in the sector. So Norsk Helsenett is responsible to measure how all the messages flowing in this network is going, how the quality is, and remember, we are not looking at the sensitive parts. That's encrypted. We're only looking at how it's transformed and that it's done correctly. And we expose this data. We have some web pages that you can see it. This has been a huge success, and these are the latest numbers. We are up close to 80% now. It has taken us 8-9 years, but with the help of this certification track that we created with the validation tools available for the vendors, it is now able to sort of see how they're going and get feedback on it. And we have created a good thing, I would say. So from now on, we know that the quality of the messaging is good. So when the sender sends it, the receiver knows what's coming in, and you can do the right things according to the standard. And traffic increased. This last year during the COVID, we had a little dip in the start of the COVID because probably people stopped going to the doctor or something. I don't know. But suddenly we had all these COVID tests. That is one of the solutions and one of the things that the Norsk Helsenett contributed largely with in Norway. All that traffic is flowing through us, and that is the peak you're seeing around 284 million messages. I know that's not a lot for systems that are doing really high traffic, but since we started at 14 million, I think that's a large increase.
The growth was huge.
Yeah, the growth is huge. And more traffic.
More everything.
Yeah.
Everything grew. So at the time we got the work on the validator started, already before that point, the sector was quite happy with the development. They had got their network, the messaging had started to flow, and they figured that, we have some more data that we want to distribute besides addresses. Norsk Helsenett, can you just do that? And so we started our journey up to the skies. Early on, the architecture was very simple. One database, one interface on top of it. You want some more data on that? Well, if you look at it, how did you set up this machine? So you look at it, and the structure is you have this normalized set of data, one service on top. How would you expand on that? Well, naturally, instead of just making a new database for what would be one table for something very related to your old data, you just put some new data beside it, normalize it, put a new VCF service on top. This is now totally the new service, never mind it being in the same host and everything, and the sector was happy. And what happened then? Well, there was more to do. The team grew from a couple of people to maybe 7, 8 people. And the sector's demands continued with, okay, you can do this, amazing. You can do things swiftly when we give you stuff. So here's more things to do. And the architecture was proven, it was sound. So what we do when more stuff comes in, well, more tables, normalize everything, new services on top, and the data flows out. Everyone is happy. Great, we are now maybe about 13 developers, something like that. And everything is getting bigger. And it's getting to become a problem for the database itself, because at this point, it's important to know that the messaging standard that was chosen has dictated that when you send messages, you should use fresh address information, fresh certificate information, not rely on the old cached version you received on a floppy disk 3 weeks ago, because that would not really, I mean, we do have the internet now in the mid-2010s, right? We don't distribute patient lists on floppy. Oh, wait, we did until 2018. But never mind that. So there's at least one request hitting the database for each message being sent of all these millions of messages. Actually, there should be 3 or 4, because the receiver should validate the sender's addresses, then they should send their acknowledgement, that should be validated back and forth, back and forth. And this poor database that we had stuffed all these things into was starting to suffer. So how did we solve this problem of everything grinding to a halt? Well, we took a look at how the world was, and the solution, quite clearly, since we have all of these complex data, make a cached version of the data needed for addressing in the database, because it's rarely updated, so why not make all the traffic hit that? On the web frontends, do some more light caching, and all flows rapidly and well, and the database is saved. Amazing. So failure kind of averted. It wasn't that bad for that long. But at this point, it was also realized that our problems at the moment were solved, but we were running up to this wall of how much pain can you inflict on this database before it dies. And that was something we wanted to handle earlier on this time, perhaps before it was an obvious glaring problem that stopped everything. So at that point, a team was created to make a high availability solution, because this was government work, the entire nation's healthcare information, the mid-2010s, putting it on somebody else's computer that is the precursor to the cloud, not really a thing. So fortunately, we were a huge hosting provider, have this amazing operations people, so we had the capacity to host things ourselves, and hey, it's software, right? So just make a new fancy high availability solution. Now, at this point, our size had grown to become a problem, because when I was Scrum Mastering this, there were something like between 20, 30 people in stand-ups, solid 20-ish about of them were developers, handful of testers, some product people. It was painful. The high availability group was separated off to a separate team that did their work, and it was amazing. We kind of partitioned the work on this huge monolith that now reached for the skies, and a lot of the overdue cleaning up was undertaken by the high availability team, and they did an amazing job. And this went on for quite a while, a couple of years, I think. And everyone was happy. New data was coming in, new interfaces were created, stuff was rapidly made and published, and happiness. And the teams were extremely happy with the cleanup being performed by the new team, which they could take under the mantle of making new stuff. Amazing. But at some point, the cleanup crew figured out that, okay, we do cool stuff. Database, what is this cache table? Why do you do cache tables? That's something you do on web frontends. What? And we are making this high availability thing. So what if we just remove that table, that code, new migration, make it be gone? And the rest of the team, well, the code went in, more features were made, the devs tested it okay, the unit test didn't complain, the interfaces looked nice. So we handed it over to the operations guys, they put it into the test environment, the testers hammered on it, produced this big stack of documentation saying that everything is amazing, the new features are actually good this time, we like them. So management was happy and they said, well, time for a new release, this quarter like last time, put it out into production. And here we started our learning journey with, as usual, to not disrupt our users. In the evening, the new package was put out, and it was a huge success. The operations guy did a couple of test calls. Everything went back out fine, and we called it a night. All was good. And we lived happily ever after. At least until my phone went off in like 2 in the morning, because at that point, the hospitals had started their big batch jobs of updating their caches and everything they want to have in case they should suddenly be isolated. Fair enough, but the database was very much not happy and nothing was flowing. So I don't remember if we reached the morning hours before the Department of Health had set a crisis staff, because at this point it was a big problem that no messages were being interchanged in the healthcare sector. And fine, we have workarounds, like sending papers with cabs, with the patients, but still bad. Fortunately, we managed to figure out a way to not lose the meager trickle of data that had gone through during the day. Apache was made, we rolled forward, and we were happy that we had learned that, okay, deploying after work hours, really not good for critical systems where we want to have people who can figure out how to fix them fast on the job when it happens. And yeah, that was the first important step of learning from that.
Yeah, this was a quite interesting day, I would say. It took us, did you say it, 22 hours to fix this problem. The solution actually was not rolling back what management wanted. It's always rolling forward. So we found the solution, we found out that we had deleted the cache, and we reinstated them. So that was how we fixed this on the spot. But it was hard to find that problem, and okay, let's try not to have 22 new hours of no traffic. So what we did was actually at the moment when we found out that stuff was missing, okay, how do we test that we don't apply during the night when we were sitting down there, stressed out, trying to figure out what was wrong, implementing something that fixed it? How can we check out that this doesn't add on to the pile of troubles we're already in? So we added regression testing. We hammered the solution before we put it out in production. And this was implemented as one of the new features that we did every time we released every quarter. So we added on more tests, basically. To do more tests, we needed more people. So we grew in size as well. More people, new procedures. It was important that we anchored down and documented that what we were about to put out was sound and in good state. So, okay, more documentation, more teams, more collaboration, more manual labor.
Really pulling hard on the brakes.
Yeah, sort of pulling hard on the brakes. This doesn't sound very agile, does it? So, but it sort of worked for us. We got this rock-solid infrastructure. We have really good guys working on it, and doing changes to them was, yeah, we sort of welded stuff down, you could say. We don't like to do changes anymore in this point of time. But we need to evolve. We evolve new and create new software. We create new solutions. And this is about the time where Helse Norge is created a great solution for you Norwegians. There's a page you can go log into, and you get some information about your health status, some pharmacy information, some...
Basically everything about you and health. If you want to
Yeah.
see who your primary physician is, it's there. If you want to change him, it's there. If
And
you
we
want
created also this great how to become a donor solution. Okay, great solution. And we have too few donors in Norway, so this is picked up by the media, and they like it. So what actually happens here is that without us knowing it, Nytt på Nytt finds out that we're going to do a live demo of how to become a donor in Norway. So Bård Tufte, I think, he logs on, sits there with his phone on Nytt på Nytt and tells the Norwegian citizens watching Nytt på Nytt Friday evening that this is how we become a donor.
really simple.
Really simple, really easy. And remember, it's in Helse Norge appen. It's something that should be up almost all the time. What actually happens is that very many people see this, they like it, they want to try it, they go into it, and we peak at around, I think, 6,000 people. And the whole thing goes dead. Really dead. Okay. This is Friday evening. Again, who's at work Friday evening? Yeah. So I think the guys came in, the alarms went off. We have this amazing organization that we have 24/7 operation central that takes all the alarms and stuff like that. But I don't think they were able to handle this on Friday night. So people came in, people started working. After Saturday, Sunday came, they got it up again. I don't know the mere details here, but it took a long time. And the reason was basically many people had to go in and push buttons and stuff on virtual machines, and services had to be restarted, and it had to be happen in certain ways and procedures and yada yada yada.
And at this point, organization had just piled up even more procedures for the sake of rolling out things slowly and safely. So then we reached a point where we realized that okay, doing things slowly and safely is fine, but that place of really amazing agility we were at in the beginning was perhaps not so bad, because stuff happens and needs to be fixed, and some of the things that need to be fixed really fast. With the incident where your primary healthcare portal for the nation went down, we started to invest more into automating infrastructure, and the hope here was really now up in the clouds, because this has started to become a thing that was available and actually used for many government functions. It was now proven to be something solid that could be relied on for many decades in the future. So let's start building there. We dipped our toes. And then this big storm of Schrems 2 happened, where no public services in Europe basically could be in the public cloud, or so our legal department told us, and we rained down back into our data centers. Fortunately, we have this amazing operations organization, and actually rather fastly they had built on, they were doing a lot of the automation around the infrastructure, and they, in short order, managed to provide us with a very full-fledged Kubernetes service on-prem. So although we were one of the few people to have the experience of porting from the skies to our basement, it was still doable, overcomable. So the world was amazing again. Now we had something that actually provided a platform where we could have scaling, and for those of our services that have really high requirements for uptime, we could start to more effectively and in ways that humans can reason about, say something about geographical redundance, And yeah, our runtime was becoming great. So again, we thought that our journey might have ended, but no, because even though our systems were now, or even though most of them are still in the transition of becoming more distributed, our data was very much locked up into these databases. And with the size of the data and the hardware we needed, the database guys were like, yeah, of course, we do continuous backups, that's good, but this to aggregate them and ship them somewhere else and spin them up, if you don't want to lose hours, days of data, takes time. So no, you cannot have a hot spare that you can reasonably use. And you want to make a live replica that continuously feeds it over in the other region. How much latency could you tolerate? No, nothing? Well, yeah, sucks to be you then. There is the one database. And for our more virtualized services, I mean, yeah, the small databases didn't have the same problems with regards to perhaps latency, but it was still so large in its virtualized system that even they were not really feasible to spread about. So yeah, at this point, we wanted to figure out what can we do about this. We are so close to now finally having something that can make us not go into all of these problems anymore.
Yeah, so what you said is that we have managed to distribute all our systems. We have Kubernetes. But our data is sort of stuck in this one SQL server or Oracle server or file server or on at least one server. We're an organization where redundancy is a number starting with 3. That's where we begin. So when our data is stuck at one place, that's not good enough. We're missing 2. So we have to add 2. How can we add 2? What we've seen is that to sort of get out of this thing of things being stuck in the database, we need to distribute the data. It needs to have other attributes than the ACID principles that we know of in databases. So we're seeing a shift here from, yeah, we have our data right there. That's our true copy, to maybe data's sort of here somewhere. And how can we implement this? We're looking for in this, or we're finished looking actually. We found that what we were looking for. What we did is look for systems, technology that gives us what we need, gives us distribution, gives us the scaling, gives us the ability to be in multiple regions with the same data at the same time. And what we fell onto or chose is Apache Kafka. For us, this gives us the ability to almost indefinitely or without a roof scale our data. But we also have to think about data not as a state in one data or excuse me, one SQL server, but as a log, never-ending log, never-ending story of events coming and streaming. And that is a huge leap, actually, in the organization and how we create our data and how we create our services. But this sort of thing that Kafka gives us is the ability to separate the production of data and the consumption of data. Separate read and write. And
yeah, so our choice then of Kafka as our event streaming system came with a lot of these nice properties with that having a distributed system was something built in. We didn't have to repeat our learnings of how hard it was to make a high availability solution. Get all these good properties surrounding, well, one thing is distribution, another thing is scaling of production. You can have many services producing to a topic, or on the consumption side, if you want to have many front ends reading some static data, you can easily scale up to have many consuming the same. And at this point,
yeah, I would also like to mention that we're in a sector where we don't like to sort of be on the bleeding edge. We have chosen Kafka because it has proven itself in actual battle. We've seen that it worked. We've seen examples, multiple places that this can be used in and be trusted on. So that is important when we are choosing a technology. It has to be safe. It has to be up to what we're going to push it through.
Yes. So for a lot of cases, that means going for things after they've proven themselves. And now that we had this situation where we have built up a flow of data that goes in a more directed stream rather than constantly jumping in lockstep with every new release and deploy, we got together at Coffee Machine and started talking about how we were going to transition our services from this model where we had one big database in the bottom, because what we saw was that many times when we released something new, we have experience with testing things and then putting it out in production and discovering that, hey, there have appeared new edge cases that we haven't tested for. Production is different than our test environments. The thing dies. Really not good. And say in some of our other cases where we updated our production environment, migrated our schemas, and figured out that, well, now we have a problem with, say, handling the amount of traffic. And can we roll back the migrations? Well, maybe. How much data loss can you live with? You're the healthcare sector. None. Well, interesting. So lots of challenges. And what we realized now was that we are actually becoming free from this state of our database being the one clock that keeps the state of the world in sync. We now actually are moving towards a place where data flows in through our topics, we use the data, and we produce output to new topics. So instead of begging people to please use the read-only connection string when you can, because we want to try to tear things apart, we are now in a place where the system gives us this out of the box. And that got us thinking about, okay, so now when we deploy things, previously we had these problems with our systems maybe choking on production data as they were put out. Could we avoid this? Could we maybe test that the systems are actually capable of handling the production data? And with the basics of Kafka, yes, we can have several consumers. So if we make a new candidate version of our API, we can put it into production and plug it into our existing input streams. But that got us thinking for a moment, because plugging things into production streams, we already tried that a couple of years ago with our SMS service. So we have this internal messaging service that lets the healthcare sector send messages to the people. So very much used during the last couple of years with everyone arriving at the airport, getting messages about please get tested and so. However, we also learned something very interesting in about 2017, I would say. where we made a new version. Some testing was being done. A very simple message: update your doctor now. And it appears that when using valid phone numbers, there are a lot of them used by actual human beings in Norway, and yeah, quite a few thousand got messages about you have to change your doctor now. So testing with production data has, there's a reason it's not best practice. So that's kind of pained us. But at that point, we realized that Kafka allows us to very easily create new topics. So sure, we can read from the input topic, but the same input topic that's used for the live production data to check that this solution, when it goes live, will actually work. But we can also just create a new shiny output topic specifically for the candidate version and stuff its output over there. This allows us to test that our new candidate version will run in production and will yield the output we expect. Now, whether that is the same as the previous stream, or there is changes, additions, or maybe it's just an internal bug fix and we expect no changes, as it often is. Then this enables us to do this verification without having the end users or the customers in this loop at all, and we can actually safely verify that it is going to work. And another really interesting part here is that being in the healthcare sector, having a lot of critical sensitive data, we can't just take the production data and put it on a developer's laptop or test environment and say, have fun, check that it works. I mean, production data has to stay in production. There's no other way. Or, well, there are fun things you can do with randomization, pseudonymization, but that's things that can go wrong in very interesting ways. So this also allows us to very safely verify that, the data is handleable, and we can handle all the weird edge cases that only exist in production, and we can handle the weird usage patterns in orders and things that we only see there. And also, if we want to test the rate things flow through, we have done lots of work on trying to make good performance testing, which has resulted in hours of creating good test sets and simple test sets and setups of pushing things through fast enough, and somebody finding a machine that can run this fast enough, and are these results actually representable? We believe so. Lots of pain. This allows us to actually rather simply do that. But at the same time, this being production, some shared resources, it also allows us to do the verification at our own pace. Say that the data can trickle through the candidate and we can verify it at our own leisure if it's not really important to test the performance now. Which is, fun in many, many ways. But now you might be saying, okay, cool, you made something that takes data from Kafka and puts data back into Kafka, and are your customers like running queries to Kafka and getting information about who their doctor is that way? I mean, the pharmacists love running KSQL, right? Well, nah.
Well, the world actually is, there are people interacting with us. So how does this work in some API world? The previous example could probably be used or done by KSQL or something else, but here's something we've figured out. This is how we could do this with within a API, REST, VCF, whatever, I don't know. You have some input and you have some output you want to send to the user. So the input comes first, obviously. The input comes in from the user. The first thing we do with that is push it to a topic. And we push enough of that input to a topic that we can later recreate that request or input. Okay, easily. obviously, most of our APIs do some fancy stuff with some data or lookups or something. So we have to connect to some data. We need to consume some data and put that into the to this API as well. So yeah, we have some data flowing into it. We do some stuff, some work. Then we send an output, and before we send that output, we put enough of that output onto a topic, and we're safe. So we save this. We save all the events here, and what we can do afterwards in our leisure time, or when we have a new candidate of that API, is that we can replay the input from the customer. Put that into a service of some kind that reproduces the input that the user made and sends this to the candidate. Well, the candidate is a true copy or not a true copy, because then it wouldn't be a candidate. We'd probably had a problem in production somehow. So we want to replay that input that caused that problem, and we want to see if the problem is solved. So yeah, we trigger that into the candidate. The candidate also produces to the input to topic, the output to a topic, and it also attaches to the data that the original API is connected to. This can be done completely without the customer knowing it. So we can implement this in production totally without implementing it to the customer.
And this is also important because while there are various techniques of releasing without releasing, you have feature flags, it's well tested, lots of frameworks for it. One of the important to us properties of doing it this way is that it allows us to keep the code really minimal and only doing what it should be doing. So instead of having all these paths out there that in some cases, most cases actually should never be taken in production, but you can take them, and you add complexity and things that shouldn't go through end up going through, really not good.
And yeah, and you can say, should you really save the input and output from the customer? Well, we are obligated to have an audit log on all our stuff. We need to know who has done what. So this is basically the same data. And yeah, we can reuse it to verify that the future versions of what we're doing actually works in production without putting it out to the customer in production.
And another interesting technique that also is well tried for putting things into production without taking down your production is, say, A/B testing. Has seen a lot of literature over the last decade. And while that is great, we are in a sector where we can't just deploy a new version of our service, run 10% of the traffic through that, and you wanted new prescriptions. Well, that's too bad because you were in the test stream today, so no prescriptions for you.
Sorry.
You have to get medicines today? Nah. Call your doctor. They can maybe send a fax. I mean, we can't.
So yeah, is this a new concept? We don't know.
We have certainly taken a lot of inspiration from other people discussing how to do testing and verification, how to not make interesting failures that take down your production environment.
Yeah. Our inspiration here is that we all do testing in production, whether we know it or not. We have taken the choice that we sort of do this with. We're very, very conscious about this. So, but yeah, that is one of the things or the trends that we have seen and followed and also been looking into. But not long ago, I saw this video with Dave Farley. He's done an interview with somebody at eBay doing mirror testing.
New words?
Yeah, new word. I don't know. Holly Comments, I know she's talked on a podcast about mirror testing, but I don't know exactly if we're talking about the same things here. What we've done here is actually mirror production environment, not totally, wholly, whole production environment, but sort of created our own space, safe space, where we can do this. If this is mirror testing, okay, then it's mirror testing. We don't know.
Try searching for it. We find nothing.
Yeah.
So, yeah, summarizing then. We have gone through an interesting journey from where we started as a really small group of people to yeah, experiencing how growth can go. We have had the fortune of working with a lot of the really core infrastructure of healthcare in Norway, and getting to see what gets it up and running and what's needed to make it not suddenly stop.
We've gone from really agile, small group, really agile, to not so agile, and we're trying to pitch back towards
Yeah.
agile, but as a large organization, because we haven't been, we are increasing in size. That's a
Definitely.
fact. Yeah.
So, and along this journey, we also repeatedly learned that while we do testing and a lot of testing, it's still only really production that is production. So we make as sure as we can that when we release something, it should work. But no matter how much you try to come up with edge cases that might exist, you will still need to actually verify that production works before you can say that it works in production. And we now believe that you have the tools to be able to be certain of that.
Yeah.
Before we really
Expose the customer to our problems. So yeah. And
but it's also important to say that while you do need to verify that your production environment works before you start telling people that, yes, go and do stuff, it's good, it's important to not conflate this with the testing you would otherwise do. I mean, your unit tests will still give you feedback a long, long time before any of this has a chance to go through your CI pipeline and be out there and tell you about whether this works. And your testers will come up with all of these edge cases that you will have to cover. So we're not arguing that replace your testing, but we're saying that verify that your production environment will work.
this is for us, this is an addition to all the other stuff that we do. So yeah. I think we're through now.
Yeah.
Yeah. Thank you for coming. Thank you for listening. If there are any questions, we could. I don't know if we have any time for that, but we could probably take that afterwards. We have a stand. Norsk Helsenett has a stand. Come talk to us. And if you especially want to talk about mirror testing and what we call mirror testing, or if you have another definition of it, mirror testing or something like that, we really want to talk to you. Okay. Thank you.